Welcome to this video session. In this session, we'll study about the advantages and disadvantages of digital signals. What are the reasons for the widespread use of digital signals? The first important advantage is that digital circuits and systems use electronic devices like a transistor, and these operate in one of the two states, on and off, which corresponds to the binary 1 and 0. This results in very simple operation, and analysis of circuits becomes much easier since you have to deal with only two possible states of the circuit. The second important advantage is that there are very few basic operations in digital circuits, and these are easy to understand. Digital circuits, they use Boolean algebra, and in Boolean algebraic expressions only two possible values are there, and those are 0, which is a false, or a 1, which is a true. Now, this is in direct contrast to normal algebraic expressions where there could be many possible answers because the numbers can be different from 0 to 1. Now, digital systems can be programmed for carrying out commands in unattended mode. What does that mean? Once a set of commands is given, those commands can be executed automatically in a predefined sequence, and this is called as the unattended or the programmed mode. The fifth important point is that digital signals can be built using only a very few integrated circuits, which are mass produced, which are cheap, they are reliable because they are produced in bulk, they are small in size, and they have very fast switching speeds. So the operation is very fast. Digital circuits are also called as switching circuits because the voltage level in a digital system changes from one value to another almost instantaneously. This transition time from one voltage to the other voltage is 0. Digital systems are not affected by electrical noise, by the temperature, and by the age of components, and the noise immunity is very high. Digital systems are suitable for processing numeric as well as non-numeric data. We do not only do calculations with our data, but we also process video, audio, and text. And this can be easily done by digital systems because ultimately all data is converted into a series of zeros and ones. Digital systems are economical to design and they can be mass produced. Of course, integrated circuits are available in a logic family. So within a logic family, all devices will have similar characteristics. So this will make it easy to interface devices, connect one device to another, and therefore you can build larger complex systems. This permits scalability, much like maybe a Lego toy. So digital circuits are also called logic circuits because each type of digital circuit that is constructed, it has or it obeys a certain set of logic rules. So the manner in which a circuit responds to its input is called as the circuit's logic. So for example, one may have a circuit whose output is high or 1 only if all inputs are 1. We'll study about such circuits in this course. Digital circuits have a very important property which is of memory. So they can remember the last state they were in. That means 0 or 1. Now this property is extremely useful in devices like computers, telephones, calculators, watches, medical devices where data has to be stored and has to be processed again. The very important advantage of digital systems is that data can be displayed in a convenient way on very large display panels, or it can be adjusted on smaller displays as per the requirement. Digital systems are also more accurate and precise because they can be expanded to handle more digits, and all we need to do is add more switching circuits. So as we said in the previous point, that these circuits can be built by joining them one after the other, and therefore more precision can be obtained. Some digital signals carry extra information that allows damaged data to be repaired at the receiver. So although digital signals are not easily affected by electrical noise, if a signal is affected or if it is damaged, due to some unwanted data or unwanted noise or unwanted signal, then this damage can be taken care of at the receiving end. So this extra bit of information that our digital signals carry can be, for example, what is called as parity information or parity data. So here are the summary of advantages of digital systems. There are very few operations and hence it is easy to understand the working of digital systems. They provide a better noise tolerance. They are not easily affected by external noise, and by noise here we mean electrical noise, that means unwanted signals. They are lower cost and easily they can be fabricated. They are more reliable, they are not affected by temperature and other factors. The power consumption of digital circuits is much lower. They are small in size, which means that these systems can be portable. Scalability is easier, which means that systems can be joined one after the other and we can have more complex data processing. These are ideal for data communication over long distance. This again comes because the signals being digital signals are not easily affected by external noise. You transmit signals over large distance. We can use repeaters instead of amplifiers. They can operate over a well-defined dynamic range. Linearity is not required. What it means is, so in a digital world, why do we need an analog signal at all? Require these. So although digital signals have many advantages, the fact remains that the real world is mostly analog. This is the major drawback of digital signals. For example, temperature, height, pressure, force, acceleration, wind velocity, these are all analog quantities. These are continuously varying quantities. So for example, the temperature of a room will vary continuously, not from one level abruptly to another level. So we must take these analog quantities and we must digitize them or convert them into a digital form and then process, preserve and propagate these digital signals. So this conversion of an analog to a digital form is done by an A to D or an analog to digital converter. So for example, here we have an analog signal which could be, for example, voice, which is converted through an A to D converter and it gives us a digital signal. You can observe here that on the left side we have the analog signal which is continuously varying. It has different voltage levels, different amplitude levels, but on the right the digital signal has two fixed values which are either a 0 or a 1. And at the receiving end, this digital signal has to be again converted by using a D to A or a digital to analog converter back into the analog signal. So what are the disadvantages of digital signals? So the conversion of real world analog signal to a digital signal and then again processing that digital signal, converting it back into analog, time consuming. Certain systems that we use will have both analog and digital systems, and such systems are called as hybrid systems. So we have seen what are the advantages and disadvantages of digital signals.